By the end of the lesson, I will be able to write large and small numbers in scientific notation given the number in standard form. Vocabulary. The first thing that you need to write down is what scientific notation is. Scientific notation is a method of writing or displaying numbers in terms of a decimal number between 1 and 10, multiplied by a power of 10. And the second thing that you need to know is what standard form is. And standard form is a way to write numbers using the digits 0 through 9. Rules for scientific notation. The first rule that you need to write down on your piece of paper is that scientific notation is a number from 1 to 10 multiplied by 10 to the power of a. It sounds very similar to the definition that you just wrote. Here is the algebraic way of writing it. So 1 is less than or equal to, so x has to be greater than or equal to 1, but it has to be less than 10, and we're going to multiply it by 10 to raise to the power of a, some number a. Here, over here is a numerical way of writing it, so 4.9 times 10 raised to the 9th power. Rule number 2 is that small numbers use negative exponents and large numbers use positive exponents. This slide's all about how to change a number written in standard form into a number written in scientific notation. So the first step that you're going to do is move the decimal to create a new number that is between 1 and 10. Be sure to indicate your moves with bubbles. You'll see that here in a little bit. Remember that the new number can equal 1 but cannot equal 10. The second part is you're going to write your new number that you've created and you're going to multiply that by 10. So you're going to write your new number times 10. Number 3, you're going to count how many spots you moved your decimal. When you move your decimal, you're either multiplying or dividing by 10. So the amount of spaces you moved your decimal is your exponent. And number 4 is your exponent, positive or negative. And how you tell is that your original number is large. If your original number is large, then you have a positive exponent. If your original number was small, then you have a negative exponent. And when I mean large, or when I say large, that means greater than 10. And when I say small, then your number was smaller than 1. So again, large original numbers are greater than 10. Small original numbers are smaller than 1. So we're going to solve some scientific notation. Using the 4 steps, write the following standard forms into scientific notation. So the first step was to move my decimal place to create a number that is greater than or equal to 1 or less than 10. So I'm going to indicate using bubbles. I'm going to put my marker on my decimal point and I'm going to move over until I've created a number that is greater than or equal to 1 but less than 10. So my new number is 1.23. My second step was to multiply that new number by 10, and my exponent is going to be how many bubbles there are. So I'm going to retrace the bubbles. I have 1, 2, 3, 4. So my exponent is going to be 4. The last question that you need to ask yourself is your exponent going to be positive or negative? And our original number was smaller than 1, so my exponent is going to be a negative. The next one, 45.78, I'm going to move my decimal 1 spot to the left because 4.578 is in between 1 and 10. Multiplying it by 10, and I have an exponent of 1. Is my exponent of 1, because I have 1 bubble, is my exponent positive or negative? And it is positive because 45.78 is larger than 10. Moving my decimal 1 spot to the right because 7.277 is in between 1 and 10. Multiplying it by 10, my exponent is going to be 1 because I have 1 bubble. And my exponent is actually going to be negative because my original number was less than 1. Moving over to the right-hand column, my decimal point, I'm going to move it 2 times to the left because 9.08201 is in between 1 and 10. I'm going to multiply it by 10. My exponent is going to be 2 because I have 2 bubbles. And I'm going to have a positive 2 because 908.201 is larger than 10. Moving my decimal 3 spots this time to the right because 2.345 is in between 1 and 10. I'm going to multiply it by 10. I'm going to have an exponent of 3 because I had 3 bubbles. And my exponent is going to be negative because my original number was less than 1. Moving my decimal place in between the 1 and the 9 because 1.9999 is in between 1 and 10. I'm going to multiply it by 10 using an exponent of 1 because I have 1 bubble. And my original number was larger than 10, so my exponent is going to stay positive. 6 more examples and then we're done. We're moving my decimal point. I'm going to move it in between the 3 and the 6. So because 3.6 is in between 1 and 10. So I'm going to multiply my new number by 10, and I'm going to figure out my exponent by moving my decimal. 1, 2, 3, 4, 5, 6, 7. I'm going to have a negative 7 because my original number was less than 1. 1.3024. That number is already in between 1 and 10. So I'm just rewriting it, multiplying it by 10, and I'm going to use a 0 because I didn't move my decimal. 10 to the 0 power equals 1, but in our case, we're just going to leave it 10 to the 0 power. I'm going to move my decimal point in between the 1 and the 5 because 1.53612 is in between 1 and 10. That means that I'm going to have an exponent of 1 because I moved my decimal place 1 point. And I'm going to have a positive 1 because my original number was larger than 10. Again, 6.08 is already in between 1 and 10. So I'm just going to rewrite it, multiply it by 10, and I didn't move my decimal, so it's a 0 power. You can also write this as 6.08 times 1 because 10 to the 0 power equals 1. Moving my decimal, I'm going to move my decimal all the way over here between the first 9 and the second 9 because 9.99 is in between 1 and 10. I'm going to count how many spots I move my decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to multiply it by 10. My original number was smaller than 1, so I'm going to have a negative 10 exponent. My decimal point is going to move in between the 5 and the 0 because 5.09172 is in between 1 and 10. I'm going to multiply that by 10, figuring out my exponent by moving my decimal. 1, 2, 3. And my number was bigger than 10, so my exponent is going to stay positive.